Assalamualaikum. I am Khondokar Asif Mahmud. I am a student of Daffodil International University. Here I am doing my BSc in Computer Science and Engineering. My batch is 63B and my student ID is 024 222 Today I am give a presentation about memory representation of trees and pre-order, in-order and post-order travels of rooted trees with examples and construction of trees for infinite expressions. If we uh, go to the our next slide, here our topic is memory representation of trees. We can do memory representation of trees by two way, by array, and the other way is by linked list. Here, if we do this by array, here we have some rules. Here we have to consider the root as I, left child as 2i, and right child is 2i plus 1. If we look into the example, here the root is a and its value is according to the rules I is equal to 1 and its left child is 2 into 1 is equal to 2 and if and its right child is 2 into 1 plus 1 is equal to 3. According to the rules, if we look the root A is left child and is right child, B and C's placement is 2 and 3. And if you again check the E, which I value is 5, according to the rule, its left child is 2 into 5, which is 10, and its right side placement is 2 into 5 plus 1, which is 11. Here its right child, if here E haven't any left child, so it's in the 10 placement it is null, and its right child is in the 11, which is I. And by this process we can find the memory representation of this by array. Then if we want to do by linked list, here we have a tree which is root is a and its left child is b and right child is c. Here a is the root, and in its left side it will store the address of its left child b, and in the right side it will store the address of its right child c. Here here if we consider the b as root, its left child is d, and on the left side of b it will store the address of its um, left child d, and in the right side it will store the address of its right child e. Here in the here beside the both side of e, here is the null node because e haven't any child, and according to the process we can fulfill this tree and complete our memory representation of this by linked list. And then if we go to the our next slide, our topic is pre-order, in-order and post-order travels of rooted trees with example. Here first we have the pre-order, and for doing this we have a rule which is root left right. According to the rules, if you look into the example, our here our root is a, then the left side we have b, then we have d, and if we consider the d as a root, we have to take the is left child g, and this left child is k. Then we have to go to the uh, right child of d, which is h, and if we consider the h as root, the left child is l, and we have to take this, and then we have to we we have to write m, and it's uh, m m uh, then we have to back to the a, and a's right child is c, and c's left child is e, and c haven't any right child, so we have completed our p order. Then we have to that we have in order, and the rules is left root right. Here here our left child is k, then our left child, then the root of k is g, and here we haven't any right child of g. Then we have to go to the d, which is if we consider d as root, then we have already completed the left child of d, then we have to go the right child of d. Here if we um, right, this right child is h. If we consider h as root, its left child is l, then we have to go root which is h, and we have to write the m which is h uh, right child, and then we have to back to the b, where we have complete all the left childs of b, and here b haven't any right child, so we have to back to the a root. And after going to the a root, we see that we have already write all the left child of a, then we go to the right child of a which is c, and if we consider c as root, then c's left child is e, and if it haven't any right child, so we have to write e which is left child, and its root is c. And by this process we have completed our in order. Then if we do post order, the rule is left right root. Here here the left child is k, then we have to go to the g, then we have to go after the left child, we have to go to the right. Here if we consider h is as the root, here we have to write first the left child which is l, then the right child m, and their root is h. Then we have to back to the d, and if we consider the b as root, here the n- all the nodes under b, if we consider these things are um, left childs, then we have to go to the right child of b, but here b haven't any right child, so we have to go to the a root. And then we see we have already write all the left child of a, then we have to go to the right child of a. Here yes, right child is c, and if we consider c as root, is its left child is e, we have to write e, and then we have to go to the root which is c, and which is c, and then we have to write the ultimate root or the main root which is a, and by this process we have to do post order. And then if we go to our next slide, our topic is construction of trees for infinite expression. Here is a infinite expression, um, which is a multiplication b division c uh, plus e division f multiplication g, plus k minus x multiplication y. If we do construction of this for this infinite expression. Here we have to maintain precedency and associativity rules. Here the plus and minus has the mean precedency, so here we have to according to the infinite expression, uh, minus is the main root, and here all the operands are leaf nodes and all the operators are are roots. And if we construction if we start our construction of this by this minus root, all the things beside the minus of this of its left side is these are its left child, and its right child is x multiplication y. Then after the minus our mean precedency is plus uh, in its in its left side, and then k is and we have to consider the plus as minus right child, and if we consider the plus as root, its right child is k and its left child is uh, plus according to precedency and associativity rules. And then the plus and then the plus right child is c a multiplication b division c, and is and division, and its right child is c, and the plus right child is uh, multiplication and multiplication and uh, multiplication, and its left child is uh, division uh, division 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 uh, ef e division f, and its right child is g. And uh, to the left side division uh, and in the left side left child of plus, here here a multiplication b uh, division c is the right child, and we have to uh, follow the the main precedency rules. Here is the multiplication and division, and we have to consider division as root, and here uh, c is the right child of the division, and a multiplication b is the left child of the division, and at last a and at last we have to consider the multiplication as multiplication as root, and then the multiplication left child is a and the multiplications right child is b. And according to the process we can construct our trees for infinite expression. uh, Thanks for see my presentation.